Thank you everyone for joining us today. My name is Harshal Pimpalkate. I'm a Senior Product Manager with Amazon Lex. In today's discussion, we want to walk you through how you can add a conversational interface to enterprise software. And specifically, we want to cover how Infor, the world's third largest ERP software provider, has added a conversational interface to their Cloud Suite ERP software using Amazon Lex. And with me on stage, I have Rick Ryder, Director of Product Management, and Manju Ganimasti, VP of Product Development from Infor. Thank you guys for joining us today. So I want to walk through a quick overview of Amazon Lex before we jump into the details of how we integrated Lex with the Infor software. We launched Lex almost a year ago at reInvent. It's a service for building conversational interfaces, also known as chatbots, using voice and text. It's based on the same technology as Alexa. So it's the same speech recognition and the same natural language understanding stack as Alexa. As you might be familiar, speech recognition and language are some of the most complex problems in computer science today. And solving them requires a knowledge of sophisticated algorithms. It requires access to massive amounts of data, access to a lot of infrastructure. So with Lex, we have put the power of Alexa in the hands of every developer as a cloud service. And by doing so, we have essentially democratized these deep learning technologies. So Lex is a complete solution. It's an end-to-end solution that provides you with speech recognition. So you can convert a speech and recognize the intent of the speaker. You can conduct dialogue management. So we support multi-turn conversations. You can create multi-turn conversations using Amazon Lex. Our philosophy is you should be able to build a chatbot once and deploy it multiple times. And this could be on multiple modalities, so whether it's text or speech, and on multiple platforms. So you could have mobile platform, you could have the web browser, you could have the messaging platforms like Facebook, Slack, Twilio, and most recently Kik. Lex is a AWS service, so it scales as your demand goes up, so you don't have to worry about that. We natively integrate with AWS Lambda, so you can implement your validation logic, all of your business logic in the Lambda functions. We encrypt user utterances in transit and at rest. Also, we have fairly comprehensive analytics, so you can actually track the speech utterances versus the text utterances. You can look at the latency of the conversation as it goes through the system. Also, you can track what we call missed utterances. So utterances that are not recognized by Lex for whatever reason. Maybe there's background noise, and Lex is not able to understand what the user said. So we track those as missed utterances, and you can add these back to the chatbot over a period of time, and thus you can improve the chatbot. Finally, we have text-to-speech. So we integrate with another AWS service, which is Amazon Poly, and we have a text-to-speech that is inbuilt into Lex. So that was what Lex was about. What does an interaction look like with Lex? Here's a sample interaction that you can see. So a user comes along and says, I want to book a hotel. And this could be part of a broader goal of booking a trip. The user says, I'd like to book a hotel. First thing we do is convert it into text. So speech to text is inbuilt, like I mentioned. So that is, you have the text, the 5 words that the user just spoke, book a hotel in New York City. The next piece that we do is we apply the language model to parse out the intent over here, which is book a hotel, and any other information that comes along with it. So in this case, the relevant information here is New York City. That's where they want to book a hotel. Once that is done, Lex engages in a conversation with the end user based on the configuration that the developer has provided, and elicits other information necessary to actually fulfill this intent. So in this case, we already know about the location. What Lex does next is find out the check-in date, the checkout date, and any other piece of information before going on to the next part of the conversation, which is confirmation. So it confirms the intent, asking if it can go ahead and complete the booking. And once the user says yes, it will go ahead and execute the business logic. So that's what it looks like in terms of a sample interaction. How do you build such a bot? Some terminology that I wanted to share with you. We'll be using this throughout the presentation today. Working off of the same example, let's say you want to book a trip. As part of booking the trip, you might have multiple goals. So you might want to book a hotel, you might want to book a car, get your flight tickets. So all of these are goals, or what we call intents, inside of a conversation. And book hotel is just one such intent. A bot can have multiple intents. The way you invoke this intent is by speaking or typing certain phrases. So for example, in case of book a hotel, I like to book a hotel, or I want to make hotel reservations, are some of the sample utterances that the developer provides as part of defining this chatbot. As the conversation moves forward, you need information to actually fulfill this intent, and those are what we call slots. So the location in this example is an example of a slot. The check-in date is another slot. Checkout date is a third slot. So those are the pieces of information that you need to carry the conversation forward. And finally, to fulfill the intent, we have a couple of choices. So you can do a server-side implementation using AWS Lambda, or you could do it completely on the client side. So we support both. So that's the terminology: intents, utterances, slots, and fulfillment. Now let's use this information to actually build out a bot. To create this bot, first you define the sample utterances. We typically recommend that you provide like 15 to 20 of these sample utterances, and that should be sufficient to build a language model. Once the language model is built, the model will actually extrapolate to match to an utterance, which might be a variation of what's listed in the utterance. So it doesn't have to be an exact match. Moving forward, you define the slots. So in this case, there are 4 slots: the location, the check-in date, the number of nights, and the room type. And these are slots that will vary depending upon your use case. One quick call out that I want to make, with Lex, we support predefined resources. So we support built-in slot types. So for location, you could use Amazon.US city, which is a pre-built or a curated list of US cities ready for you to use. So you don't have to define these all over again. You have the check-in date, which is Amazon.date, again, curated and ready for you to use. And nights, which is Amazon.number. Also, you can define your own custom slot type. In this example, room type is a custom slot type, and you can have your own values in there. So once you've built a bot, to have it set up for interaction, you define a few prompts. And the prompts are of 2 kinds. One is to elicit information, prompts that ask questions. For example, which city will you be staying in, or what's your check-in date, how many nights will you be staying. Those are examples of prompts to elicit information. And then there is a confirmation prompt. So at the end of the conversation, just before you execute the transaction, there's a confirmation prompt asking, can I go ahead with the transaction? So that's another piece that you define. And finally, the fulfillment, wherein you have a choice between AWS Lambda function, which would make up for a server-side fulfillment, or a client-side fulfillment, wherein you return the parameters to the client. So that's how you build a bot. And that was the overview I wanted to provide. Switching gears over here, talking about conversational interfaces as a whole, conversational access has quite a few benefits. To talk about the top 3 or 4 here, it's natural. So that's how you first learn to interact with your environment. It's on demand, so you have it right away. It's really accessible. You can actually be hands-free. You can use voice navigation in a conversational interface. And finally, it's efficient. So you ask a question, and you get an answer right away. So those are the benefits of an interface, and that is what makes it a good fit for enterprise software. So if you look at enterprise software today, and I have experts on the stage who are going to talk more about this in a bit. But if you look at enterprise software today, it is complex. There are reasons for it. It is continuously evolving based on user requirements. It is very customized based on these user requirements. Some of these are also compliance needs. It is very domain specific. So every domain has its own set of needs, and the enterprise software has to fit, has to be modified continuously to fit these different domains. As a result, what happens is your information is spread across multiple different screens. It is across multiple workflows, and this makes it very difficult to find information in such a system. So a conversational interface would be beneficial in this scenario. And for some of the same reasons I mentioned earlier. It is easy to find information using such an interface, whether it's voice or text input. You just ask a question and you get an answer. You don't have to navigate like 30 different screens to get the information that you're looking for. Also, as your software evolves to the changing needs of your users, to the compliance requirements, the domain, you can actually keep the interface itself consistent. The interface does not change. You can have different workflows supporting that interface. You can have different systems supporting that interface. But the interface is a constant, and that's what your users need. So with that, I'll hand it over to Rick. Infor has actually used Amazon Lex to integrate with their Coleman AI platform. And Rick and Manju are going to walk us through how they accomplished this. Rick?
Thanks, Harshal. So I'm going to burn through these slides pretty quickly because we've got a couple of different demos that we want to focus on for the most part. But the first thing we want to do is start with a quick Infor overview. Harshal kind of alluded to it a little bit, but we're headquartered in Manhattan. We are the largest privately owned enterprise software provider and third largest, generally speaking, globally. We have over 90,000 customers and over 71 million cloud users. So what this presentation will highlight is really our multi-tenant strategy applied to AI services and how we adapted an intricate and sophisticated design to execute, in this case, what we call Lex skills, otherwise known as chatbots. But based on our strategy, we call skill sets due to the unlimited ability to customize and create from scratch some of the things that Harshal alluded to in the enterprise world. So Infor's differentiation comes in the form of 22 industry-specific micro-vertical cloud suite solutions. And our intent is to provide skills in conjunction with Amazon Lex to every one of these solutions out of the box. So skills related to general inquiries, task automation, analytics, et cetera, for each and every one of these tailored solutions, but with the ability for customers to also customize and create from scratch. To date, we've identified and we're actively developing over 250 specific skills across all of these different industries. But ultimately, what this means is that we are bringing intelligence to the core of every single one of our cloud suites. So across all of our cloud suites, we have one horizontal technology solution called InforOS, which is the group that Manju and I are a part of. InforOS is responsible for the core technology and user experience innovation across Infor, and comprises all the different products and themes that you see here, which includes social collaboration, workflow management, common security, IoT, etc. The Infor Coleman digital assistant with Amazon Lex is a part of this overall technology platform. And actually, a quick note on the Infor Coleman name. Coleman gets her name from Miss Katherine Johnson, the famous NASA mathematician featured in the film Hidden Figures. And we've got a great movie on that we released at our Inforum event, if you want to go check that out on our website. So let's quickly discuss what we mean behind the strategy of Infor Coleman, which represents our entire AI solution and platform across all of our Infor products. The first key pillar we have in our AI strategy is the digital assistant. In this case, it represents our solution in conjunction with Amazon Lex, and Lex helps us power the ability to execute skills to perform, again, the quick Q&A with a system expert, perform self-service analytics, and quickly automate tasks via what we call our Ion API gateway. We are also able to repurpose a lot of the Lex APIs to allow for some of the customization you will see today with the product and custom skill builder, which Manju will demonstrate. However, we also have initiatives underway, as you see here, related to image recognition and analysis, as well as a platform for building science-based, machine learning, and cognitive intelligence-based solutions. But all of these solutions will ultimately have connections back to the digital assistant with Amazon Lex via our Ion API gateway, again, with a connection into Lambda. And we have more to come on this as we show you sort of the architecture behind this. So Coleman as a digital assistant has the ability to respond and execute requests and skills that, again, are highly specialized to the task at hand. And as you can imagine, conversational UX is at the heart of this strategy, where Coleman interaction, just like Lex, is available in either text with our real-time Infor chat solution, which you'll see, or voice. And with strategic direction in all reactive, proactive, and predictive use cases, Coleman plays these three roles for us to provide instantaneous advice and help augment and or automate work across the entire enterprise. So here's a screenshot of what I just mentioned, the Infor chat, which you will see in the demo here in just a few. But I wanted to quickly describe what we mean by the two interaction mechanisms, which, by the way, we plan to increase here in the very short-term, near future. But within chat, Coleman is always available as a persistent user, but I can also bring Coleman into a group conversation as well and ask those same questions. So here I can type and interact to perform against a Coleman skill set. But let's say the user's not in the context of chat, or they don't have a chat window open, or they just want to execute something quickly with voice. Now within our portal header, we use the tap-to-talk profile, as it's called within Amazon Lex, to enable contextual interaction within every single screen connected in our InforOS solution, and execute against that same exact Coleman skill set throughout the entire enterprise. So before I turn it over to Manju, I want to give a quick look at a demo into our user experience for our enterprise users.
Today, we are announcing Coleman. AI has already entered the mainstream, and it's making our lives infinitely easier. AI is the new steam engine, the new electricity, and it will transform everything. Our job at Infor is to bring it to the enterprise and the industries that we serve.
Let's quickly take a look at some of the capabilities of Infor Coleman. With a focused connection into our API gateway we call the Ion API, we've repurposed and added our own spin to the Amazon Lex toolset to enable tenant-specific deployment and management of AI skills. Therefore, using Coleman, we can automate any request or task both within our Infor ecosystem or even external systems through our secure and certified Ion API gateway. Once we authenticate a user into InforOS, our horizontal technology cloud suite at Infor, we can access Coleman through a couple of different ways. First, through InforChat, our latest evolution of our collaboration strategy, where I can have real-time conversations with my colleagues around groups and topics, or one-on-one interactions where Coleman is always available as a persistent user, always readily available to answer any questions or assist with any task. So for instance, I can request contact information from user profiles, like, what is the email address of Massimo? Or, what is the phone number for Emily Williams? Or let's say I want to automate a process that is maybe time-consuming or a bit difficult for me to find in my environment. For instance, setting up an out-of-office request. I'll navigate to my user profile quickly to show that this has been disabled. But now if I go back and establish my intent, I'm going on vacation. Coleman asks for a start date and an end date. And finally, an option to delegate my tasks and alerts associated to any of my workflow-related activities, and in this case, I'll pass those off to my colleague Manju. Once I have the confirmation, let's go back to my user settings, and now you can see how that API has been executed in accordance with my parameters to cover both the date range and the delegated activities. But perhaps something a bit deeper and more complex. What if I need to query my connected GHR system, maybe for a skill evaluation for an employee? Here I can also ask Coleman, what skills does Michael Lee have? And I'm shown the list directly out of our Infor product, where perhaps it's several screens away, or I'm a manager unfamiliar with the associated screens, and I just need the information quickly. But to take that a bit further, maybe I need to know, what proficiency does Michael Lee have for his clinical monitoring skill? But just to be sure, let's check our source here. Another standard skill we offer is natural language voice navigation. So let's just request, navigate to the skill management screen for Michael Lee.
Taking you there now.
So as you can see, we can just request what I'm looking for or where I want to go, and Coleman can automatically help guide me. And the onboarding implications for this type of use case is massive with our users. But here I can check that indeed the Coleman response matches the skills listed for this employee, as well as the exceeds expectation rating on the clinical monitoring skill. Now a second way I can interact with Coleman is by voice, which you just saw with the voice navigation feature. We have Coleman available in our InforOS header, which persists throughout all of our applications, and using the Lex tap-to-talk profile, I can execute against the exact same skill set. So let's say I now know enough about Michael and I've received nominations to promote him, but for the sake of argument, let's say it's too tedious of a process to execute, or I just want to do it quickly. Let's go ahead and promote employee Michael Lee.
Great. What position would you like to promote to?
Vice President.
What management reason would you like to cite?
Executive Off-Cycle.
And what's the effective date?
December 1st.
Great. The promotion has been submitted for processing.
One less thing on my list completed in seconds. But let's now alter my use cases over to another one of our micro verticals, food and beverage manufacturing. I need to check the lead time on an item.
What is the item?
Orange juice.
And what is the warehouse number?
132.
Lead time is 5 days.
Or then if I try to execute an operation I'm not authorized for, create a purchase order for orange juice.
You do not have permission to order while inventory levels are within tolerance. Please contact Michelle Rose for any requests to override.
And lastly, we have the mobile APIs to extend this to mobile scenarios as well. This was just a snapshot into our Coleman Digital Assistant capabilities, and we are just scratching the surface of what we can offer with InforAI.
with that, I will turn it back over to Manju.
Thanks, Rick. You saw the demonstration of Lex and Coleman. Now I would like to go over like how we have built this behind the scenes, what is the architecture, and let me start with the reason of why we are using Lex. Alexa is one of the leaders in the personal assistant market, and it's been in there for a year or two already, and so it's the market leader currently in this area, and Lex uses the same technologies that Alexa is built on: natural language processing, deep learning, and automated speech recognition. And we wanted to build our Coleman platform on the same kind of technologies and on a technology that is already widely used, and Lex was a natural fit. Next one was in terms of the consumer space, Alexa is the leader, and so you can see the skills being built from different companies that are in the consumer space, like for ordering pizza or booking tickets or checking the weather, etc. So it's relatively easier to build skills, and it's in a specific area. For us on the enterprise side, we wanted to use a technology that was more helpful for the enterprise, and you will see why it is slightly different compared to Alexa, and Lex had a solution, and it was a natural fit for us actually. And in the enterprise side, so it is not like we ordering pizza or getting weather information. It's more complicated than that. There are a lot of business applications that are given to an enterprise. So if most of you are maybe coming from enterprises, and there are a lot of applications that you use in your companies. And to provide these kind of skills to a company, there is always changes. They have their own requirements, modifications, customizations, and there is always requirements from the customers that they want to build their own skills. And Lex had the right solutions for us to build our Coleman solution on, and that was one of the reasons. From the APIs wise, Lex, right from the get-go, it had APIs for both configuration of the skills as well as the runtime. So they had both the config as well as runtime APIs, and that made it very easy for us to pick Lex for this. And you also saw the examples of Coleman. So we had like voice input and voice output, and you saw the text input and text output as well. Lex also has the capabilities for voice input and text output, as well as the text input and voice output. So all the 4 combinations are supported. And you saw 2 use cases in the demonstration, but we do have other use cases, other combinations of use cases as well, and Lex already had it. Finally, Infor Cloud Suite has used a lot of, almost all of the Amazon technologies underneath the hood, and Lex was a natural fit. We have been able to build scaled solutions with zero downtime upgrades with Amazon technologies for 4 to 5 years now, with millions of end users, and Lex was a natural fit among that set of services that we use, and that's the reason why we picked Lex. Before I go into the internal architecture of how we are using Lex in Coleman, I would like to talk a little bit about the deployment architecture of Infor. Infor has about 90,000 customers, and we have our multi-tenant solution deployed in 5 regions. And in each of these regions, we don't share the data. So the data in each region is specific to that is specific to the customers belonging to those regions. And in each region, we support multiple cloud suites, right? So some of them may be human capital management, HCM, or healthcare, or manufacturing. So the financials, etc. So there are different cloud suites in each region. So and our customers use different combinations of applications. They may be picking one prepackaged cloud suite, or they may be picking a combination of business applications in any of the 5 regions. So this is a completely different deployment compared to any of the the customers that have delivering Alexa-based skills, right? So if you have a weather, so it's probably single deployment somewhere, and it's one skill or two skills maximum, and it's, they have their own complexity, but from the skills perspective, it is a lot more simpler compared to the deployment architecture we have actually. So overall, so it's a multi-tenant solution, and with multiple regions and the data spread across multiple regions as well. And each customer has a specific combination of applications, and each application comes with its own set of skills. So the set of skills that one customer gets may be completely different from a set of skills that another customer gets, or there may be overlaps, or there may be customizations that each customer may have their own set of skills that they may have built. So with that, so I'll just walk you through the architecture. So internal architecture is how we have built the system. So there are two pieces. One is the skill builder, so using which our customers can build their own skills. So it is not the standard skill that we deliver, but the customers can build their own skills, or they can change or modify the prepackaged skills that we provide to them. So we do provide for every product, like for example, HCM comes with its own set of skills, and healthcare comes with its own set of skills. So we prepackage the skills, but in addition to that, the customers can build or modify the skills. So we'll start with that. So it's a skill builder that we have developed, which I'll demonstrate in a few minutes. It's a web-based application built on Angular, runs on the browser. Most of the UI elements are in the browser, runs on the browser, and it interacts with our homegrown API gateway solution called Ion API. So all the interactions happen through OAuth 2.0, and before that, the skill builder would have authenticated using SAML, and we convert the SAML token to an OAuth token before the Angular-based web application can interact with the API gateway to create skills. So we have built our own APIs for Coleman skills, so for both configuration as well as runtime. So the Coleman skill builder will interact through the Ion API gateway and interact with the Coleman APIs, the Coleman configuration APIs, to create skills. From the Coleman API standpoint, we store the skill definition in our database, and in addition to that, we submit that information to Lex as well, using the Lex configuration APIs. So that means that the definition of a skill is there in our database so that we can manage it, and in addition to that, it is there in the Lex system as well. The reason why it is there in our system is that it will be needed for us to fulfill the request ultimately. So I'll walk you through that. So that's the flow on the configuration side. And from the runtime, we can execute the skills in multiple systems. So you saw one example that the skill was executed in our chat platform. We expose these as APIs as well to our customers so that they can build variety of applications that can run the skills, execute the skills as well. And you also heard Rick mentioning about the mobile application that we have built for chat. And we have different mobile applications for different areas as well, cloud suites as well, like HCM comes with its own mobile application. So our mobile development teams can use this API to execute certain skills as well. So starting from the runtime, so Mingle Chat also interacts with the Ion API gateway. And again, the Mingle Chat application is also authenticated. The end user using Mingle Chat also gets authenticated using SAML with the customer's identity provider. So it's not like we are authenticating against Amazon for all the users, Amazon's identity for all the users. Each customer or each end user will be using their enterprise identity provider to authenticate, and then using OAuth, we convert the SAML token to OAuth and use that to interact with the gateway. From the gateway, so again, it uses the Coleman APIs, but in this case, a runtime endpoint of the Coleman APIs. The Coleman API system in turn submits the utterances from the users to the Lex runtime system. So this may be a recording if it's a voice request, or it could be just a text, a string that is passed to the Lex. Here, we need to ultimately pass the security details as well to the Lex runtime, because ultimately we need to fulfill, our ERP systems need to fulfill the request. So we need to send some kind of information about the user who is making the request. So we do not pass the OAuth tokens directly to the Lex system. So we have built our own, we convert the OAuth token into a one-time token that we pass to Lex. So we don't pass the OAuth token as it is. The Lex analyzes the request. So if there is a valid intent that it can map to, so it is going to map, it is going to call an AWS Lambda function to fulfill that request. But in this particular case, what we have done is that we have used one Lambda function to fulfill all skills from all customers in a specific region, so that our customers don't have to go through the complexity of writing the Lambda functions to fulfill their incoming requests. So we have one Lambda function, so irrespective of the intents or the utterances of the customers, like how many ever intents they want to use. So there is one Lambda function using which we process all the requests. And the Lambda function, that single Lambda function passes the information through our backend service, and our backend service interacts with the skill definitions, and it will look into the fulfillment details as to what API needs to be executed for the incoming request. Once it figures out, it also needs to make the call to our API system, API gateway. Here what we do is we convert the one-time token into an OAuth token that was used. So basically we store the mapping of the one-time token to the OAuth token, and before the Coleman backend system makes a call to the API gateway again to really fulfill the request, because ultimately we need to go to a backend system like a HCM system to submit the PTO request, right? So to make that call, all requests to the API gateway are authenticated and needs to be through a OAuth token. So before the Coleman backend system makes a call to the API gateway, once again, it converts the one-time token back into the OAuth token that was used by the user at the beginning. So ultimately, the same OAuth token that was coming from the user is ultimately passed to the API gateway once again. It's just that in between this path, there is a one-time password, that is one-time token that is passed, so that we don't share the OAuth token with the Lex service. Finally, the API gateway based on the request. So API gateway request, so it is passed to the appropriate backend system. So it can be, the request can be going to any of our Infor applications, or it could be going to a third-party system as well. And if there is a need for orchestration, because most of the times one API is not sufficient to fulfill a request. So there may be 2-3 API calls that need to be made. So that is handled in our API gateway. So we have built those capabilities in our API gateway to do orchestration if the same request or if one utterance needs to be mapped to multiple API calls on the backend. So in the same way, similar architecture works for any other client. So it may be our own client, our chat mobile application, or any of the clients. So it may be a thick client, or it's a web-based client, or a mobile application that our customer builds. They could use the same infrastructure because everything that we build, we expose as APIs through our gateway. And so let me just walk you through some of the complexities on the customizations. So we deliver prepackaged skills to our customers. So if I talk about a PTO request, so that the demonstration of which you saw a few minutes back, so we developed this skill and on our side. We create this skill, we have this content available, and whichever customer purchases the HCM Cloud Suite, so this skill is automatically available to them off the shelf. So let me take one example. So let's say if it's customer Alpha, and they are in US East, and they have purchased our HCM Cloud Suite, and we have provisioned that to them, and automatically the PTO skill request is available to them, and they could use it. And the way in which the solution is architected, that skill will only access data pertaining to that customer. If we have another customer, so beta, in the US East itself, but they prefer to customize our PTO requests. They want to modify the skill. They may be modifying an utterance. They may be adding a new utterance, or they may be tweaking some things relating to the API request back to our system. So they may be using a different API on our HCM system. So we allow that. And finally, it may be in a different region. So we may be in, there may be a customer called Gamma in Frankfurt or Ireland. And they may have, again, customized the same standard skill that we provide, and they may be using a customized version of our skill. So what it means is that across the regions, there may be different customers using a variant of the skill that we deliver. So which you don't see in a solution like Alexa, so where, for example, a ticket booking, movie ticket booking skill, so it's standard. Everybody uses the same skill. Maybe there may be variations based on the region, but overall, most of the consumers in US would use the same skill. So in our case, it's slightly different. So with that, so let me switch to, let me demonstrate now demonstrate how to build the skill. So with our Coleman, let me just So this is our Coleman skill building user interface. It's a web-based user interface, but ultimately behind the scenes, it's going through the API gateway. These are some of the skills that we have already built, like for example, disable out of office. So this skill is already there, and I will walk you through the details of this in a few minutes. So let us start with building a skill. And this is the power that we want to give to our customers so that they can build these skills on their own. So instead of just using our skills, the prepackaged skills that we deliver. So we have a wizard to walk through the skill. So first is the basic information about a skill. So I'll build a skill called enable out of office. You saw the runtime demonstration of that, but I'll just go ahead and build the skill. So enable office. So this is the ID. So this is the ID that we use on the Lex side as well. So this is the same ID that we use. An ID is needed in Lex, and it does not take spaces. So I'll give the name. HCM. And so in Lex, you have to create skill in each language. Currently, English is supported, and Harshal is going to talk about the languages in a few minutes, but you need to specify which language the skill is being built. The next one is you heard about slots and utterances. So we have called them as requirements. So for a PTO request, there are 3 requirements. One is what is the start time, what is the start date of your vacation, what's the end date, and whom do you want to delegate your work. So I'll start with the start date, and the data type is date, and end date. And whom do you want to delegate? So these are the questions that are asked to the user. So those are our requirements. Now we need to submit some utterances. So I'll say, I'll just enter 2 of them, as Harshal mentioned. So it's optimal to enter about 15 of them, and after that the system starts learning and adapts. So those are the requirements. So the first half is the requirements, and the second one is utterances that you want to use. And you can use these placeholders as well in this. So there is a confirmation prompt. So once the requests are taken, so from the user, the Lex can provide a confirmation. In this particular case, I'm going to skip the confirmation. So the next one is the fulfillment. So how do we take these inputs from the end user and make a call to a backend system? So in our case, we are not allowing the customers to write Lambda function here. Because we know our APIs, we have built search capabilities on our APIs. In this case, we'll start with a simple one. So there is an API, I need to know which API to use, and I need to know the path of the API. So in this case, since we are using the gateway, so we already know the what is the host name, port number, and all, but it's just what we are looking for is the relative path of the API, and in this particular API, so there is a placeholder called user GUID, so that we need to figure out how we are going to provide, and it's a post request, and as part of the request, ultimately we need to give the data to the backend system. So the one of the variables in the path is user GUID. So in our case, so we can pick the user GUIDs from certain implicit variables, because since it is authenticated users, in the context we always know which user is making the request. So it is kind of an implicit variable, or also you can pick the inputs from the requirements or the slots. So in case of the user GUID or the user identity, I'm picking the user GUID from the implicit variables, and then of course it's a post request. So there's a JSON body or an XML body that needs to be submitted, and so I'm going to take the sample one here. So this is a sample JSON. So here there is a JSON request with the attributes, and these are all the placeholders that are coming from the requirements. That means that when we execute the skill, we ask for all these details, and these placeholders are replaced with the actual value that is provided by the end user. So I'm going to continue here. That's on the input side. On the response side, once the API call is made, you get a response back, and that is in REST, that may generally be JSON. And in this particular case, it's a JSON structure with multiple levels. So we are flattening that out using JSON path. So you can define multiple variables, like for example, status ID here. I'm going to copy a JSON path for that one from the response that we are going to get. So we could flatten out all the responses using JSON path and have 2, 3, because generally in this kind of an interaction, so you would have 2, 3, 4, or maximum 5 pieces of information that you need to give back to the end user. So in this case, I have used status ID, and based on the HTTP REST request response, so I can define the message. So in this case, I can say your PTO request has been successfully submitted. And you can add more responses, and in the future versions, we are also looking at how we can build it in such a way that I can also look at different pieces of information in the REST API response, and based on that, I can make a decision whether the request was successful or it failed. And also, I could use these variables as the response as well. So I can place these response variables in the response message that we are going to provide to the user. So that's the whole process of skill building. So we gave the name, description, and we gave the requirements, so or the slots. We gave the intents and utterances, and we told which API call to make and what would be the template of that request and what are the placeholders that you need to replace from for the request, and also the response, and what are the response variables and what is the message that we need to deliver. So I'm going to click create. So once I create, so this one is going to save it in our database, and in addition to that, it is also going to make a call to Lex. So I'll switch to the AWS console, and so this is the bot. So InforOS demo bot, so that you can see it's building. So basically, our system has submitted through the Lex configuration APIs. We have submitted the request to Lex, and we have submitted the request to Lex to build that bot as well. So we have created an intent, and we have added that intent to a bot, and we have made a request to build that bot. So we'll just wait for that bot building to be completed. So you can see that is complete now. So it's in ready status. So InforOS demo bot, and the intent would have been added as well. So the new intent called AWS demo enable out of office bot is submitted. So now if I go back, and as an end user, I will check my PTO status. So it is enabled, and this information we are getting it from our HCM. And I'll go back to our chat system. As Rick mentioned, so there is a user called Coleman, which is always going to be there and integrated with Lex. And I'll go ahead and so it says what is the start date. So that is day after tomorrow. Say what is the end date. I'll say next Wednesday. Whom do you want to delegate? Rick? So your PTO request has been submitted. So I'll go back to my user settings. Look at my PTO request. My out of office is enabled, and it is from day after tomorrow to next Wednesday. I think that next Wednesday is 6th, yeah. And it's delegated to Rick. So what I did was that as an end user or as an administrator of the customer, I was able to create a bot without writing a single line of code actually. And we pre-package these things, but we also let the customers build these bots as well. I think yep. So that's pretty much what I had, and I'll hand it over to Harshal.
Can you guys hear me? Okay, great. All right, so moving forward, we have a few minutes to go, like 8 minutes to go. I want to quickly wrap this up and want to take questions. So in the next few slides, I want to quickly recap the building blocks that Amazon Lex provided to make this integration possible. And so first requirement that Infor had for us was a baseline conversational interface. And this included the modality, so speech in, speech out, speech in, text out, all the different combinations. Also, the requirement was it should be hands-free or voice navigation was a need. So we'll talk about how Lex accomplished that. Second, like Manju described, the application deployment and application deployment at scale. So you have thousands of customers who are going to use this to build and to connect to bots. So how do you do that from a platform perspective? You need lifecycle management. So that's the second piece that I want to highlight. And the third piece is multi-tenancy. Because there are different customers and each one has their own custom and pre-built skills, how do you ensure granular access based on their application, based on the permissions that they have? And finally, it is the integration with the other AWS services that we'll briefly touch upon. So the conversational interface itself, the first piece is modalities, and Manju covered this. All different combinations with Lex are possible with speech and text. The same bot can support speech and text, so you don't have to write a different bot or a different skill to make this functionality possible. Second, and this is an important piece with Lex, we use the sample utterances that the developers provide to build not only the language model, but also the speech model. And what this does is your speech model is better tuned to the utterances or to your specific bot or skill. So that was the second piece that we provided. As part of the voice navigation, also we support SSML tags or simple speech markup language. What this does is, let's say you have a phone number like 800-008-7942. Instead of saying 8 billion, something crazy like 89,742, the SSML tags will allow you to read out the number as 800-008-7942. So that's another piece that we provide inbuilt into Lex. The third, and I covered this earlier, comprehensive analytics. You can keep track of your missed utterances. And finally, that it's multi-platform. So you can do it. You can build a bot integrated with a web browser, like Manju described, but also deploy the same bot to a mobile platform or to any of the messaging platforms. The second piece is the application deployment. And with Lex, we provide fairly powerful lifecycle management tools. One is the versioning capability. So every time you build a bot, it creates a new version. And the same applies to the other resources like intents and slots. So you have a fairly structured, hierarchical resource set available to you. Also, you can apply an alias to each of these versions. So let's say you're pushing your application through a dev stage and prod lifecycle. You could have an alias for dev pointing to version 1, alias for stage pointing to version 2, and alias for prod, which is pointing to version 3. So as you continue development on your version 1, your prod continues to point to version 3. So it's not impacted by your development work. So that's the lifecycle management that Lex provides. Native dialog management. The requirement from Infor was they wanted to build custom bots for each of their customers. They should have the ability to do that. And with dialog management, you can define your own set of utterances, your own slots, and have your own model. So it was possible to do that at scale. And finally, the Lambda integration. So Lex natively supports AWS Lambda integration, and Manju described how this can be used for fulfillment. You can also use it for validation at every turn of the conversation. And the third piece is how do you do this for multi-tenant in a multi-tenant environment? The requirement here was multi-tenancy, but also resource access, and that too at scale. So with all our APIs, we have granular access, meaning you can define IAM roles and ensure that a certain set of users have access and what kind of access opposed to the other set of users. So that's one. Second, authorization. So these resources are shared. Again, we could use the roles to define which users have access and which don't. And finally, like I described earlier, the built-in slot types that we could use to expedite development of custom skills. So with that, we come to the end of the session. I'll open it up for Q&A, but really quickly, we have these resources online if you'd like to review them. And if you have any questions, please feel free to reach out to us. Rick? Any questions? Thank you. Yes. Yes.
For the Lex team,
yes.
Do you have some plans to support Facebook Messenger account linking in your out-of-the-box Lex integration?
So by account linking, you want to link your Facebook Messenger account to a different account.
Yeah.
Yes. So that is something that we're evaluating as a high priority. But at this point, I don't have a specific timeline to share. But it's something that we're considering for sure.
Okay. And from the Infor, I'm just curious why you are not passing your OAuth token to Lex. Do you have some security concerns? Is it a long-lived or short-lived token? Why you are creating temporary solution or indirection?
Yeah, the main reason is there is no reason to send it actually. So there is we shouldn't be. There is absolutely no reason for us to send the OAuth token to Lex because there is no need for Lex to have it actually. And also, if you say the OAuth tokens are valid, like maybe for a day, maybe for a month, maybe for 3 months, and we don't know what they're going to do with that, where they're going to store that information. So it's like if they don't need it, there's no need to give it to them actually.
Okay.
And if I could add to what Manju just mentioned, we have two kinds of attributes. One is the
Request
session attribute, and the second is request attributes. So we recently launched request attributes. Think of these attributes as request attributes as a one-time attribute, meaning they are not persisted or stored on the Lex side. Also, you can encrypt data going into the request attribute. So let's say
That was exactly my point. If you apply the token as a request attribute, you should not be afraid that it will be persisted at rest.
Yeah, so that's a feature we launched very recently. And that's something exactly for the use case that you surfaced.
Okay, thank you.
Customers are using it. Yeah. Thank you. Other questions? Okay, thank you very much.